Welcome to Lesson 7 of the GAMS training. In this lesson, we will focus on advanced file management. In this lesson, the user will learn how to import and export data stored in an Excel format, use the put writing facility to output data, and split the GAMS program into different files. Until now, we have managed data entry in GAMS by using parameter, scalar, and table statements, and by using direct assignment. We refer you back to lessons 2 and 3 for a review of these methods. These methods may have been appropriate for simple models requiring limited data, but when using a large database, these data entry methods are less efficient and lead to typing errors. And the output data presented in a list file automatically generated when running a program is not particularly user-friendly. One option is to import data from or export data to Excel files. But since GAMS cannot read or write directly Excel files, we use GDX, an acronym for GAMS Data Exchange, as an interface to convert data in an Excel format into a format compatible with GAMS. The easiest way to produce GDX files from Excel files, and vice versa, is to use the GDX XRW utility. This utility is installed automatically when downloading GAMS. We proceed in 2 steps. To import data from Excel, first the Excel or XLSX file is converted into a GDX file, which is then read into a GAMS program. To export data to Excel, first the GDX file is created in a GAMS program, then the GDX file is converted into an Excel file. You will learn how to execute these steps in the following slides. First, how to import data from Excel into GAMS. As mentioned earlier, we import data from an Excel spreadsheet in 2 steps. First, we create a GDX file from the Excel spreadsheet. Next, we read the GDX file in the GAMS program. To illustrate the process, we return to our example in Lesson 2. In Lesson 2, if you recall, the transport model required the following data: the unitary cost of shipping, parameter C, the production capacity of each plant, parameter A, and finally the demand by each market, parameter B. For our purposes, these data are included in an Excel file named Lesson 7 XLSX in 3 different spreadsheets. Values for parameter C are shown in spreadsheet cost. Note that the Excel extension may be XLS or XLSX. GAMS support both versions. Note also that labels for the sets I and J must be spelled exactly the same in the Excel file and in the GAMS definition. We cannot stress this enough, it is often a source of errors. So Seattle is spelled the same way. If you recall, GAMS does not differentiate between lower and uppercase letters. Same thing for San Diego, and so on for each market location. While the spelling of labels matters, the order does not. Labels do not need to be in the same order in the Excel file and in the GAMS definition. Data for parameter AI is in the spreadsheet capacity, and data for parameter B is in the spreadsheet demand. You should save the Excel file and the main GAMS file in the same directory as the GAMS project or GRP file. If the files are in different directories, the syntax for importing and exporting data must be adapted to specify the location of the data. The program shown in the following slides assumes that all the files, Excel, GAMS, and GRP, are in the same directory. You will notice that the first portion of the GAMS code is exactly the same as in Lesson 2. You must declare sets and parameters prior to importing the data. To transfer the data from the Excel spreadsheets into a GDX file, we use the $call command. In GAMS, this command must be written in a single line. But for reading purposes, we have divided the command in 4 short blocks. In the first block, the $call command instructs GAMS to execute the GDX XRW utility. This utility reads input data from an Excel file and converts it into a GDX format. We name the resulting file data GDX. The syntax is as follows. The $call is a command that calls an external program. Remember that the $, when introducing a GAMS option, must appear in the first column of the line. GDX XRW is a utility that reads and writes Excel spreadsheet data into GDX files. The following arguments indicate the input and output files. I= specifies the name of the input file, Lesson 7, Excel. O= specifies the name of the output file, data GDX. In the next 3 blocks, arguments describe the data and its location in the Excel spreadsheets. Par= identifies the parameter to import. In this case, it is name A. RNG identifies the range in the spreadsheet where the data is located. It first indicates the spreadsheet capacity, followed by an exclamation mark, and by the cell range A2 to B3, where the data is located. Note that the area specified by the cell range includes the labels. RDIM= specifies the row dimension of the parameter A. It indicates the number of columns used to define the labels for the rows. In the spreadsheet, index I labels are in the first column of the data range, so RDIM = 1. In the third block, we proceed in the same way for parameter B. Par= identifies the parameter to import, B in this case. RNG= identify the range in the spreadsheet where the data for B is located. It first indicates the spreadsheet demand, followed by the exclamation mark and by the cell range A2 to B4, where the data is located. Again, the area specified by the cell range includes the labels. RDIM = 1 specifies the row dimension of the parameter B. It indicates the number of columns used to define the labels for the rows. In the spreadsheet, index J labels are in the first column of the data range, so RDIM = 1. Finally, we proceed similarly for the last parameter C. Par= identifies the parameter to import, C. RNG= identifies the range in the spreadsheet where the data for C is located. It first indicates the spreadsheet, cost, followed by an exclamation mark. and by the cell range A2 to D4, where the data is located. Again, the area specified by the cell range includes the name of the elements of C. And since the parameter C has 2 dimensions, we specify 2 arguments. RDIM equals specifies the row dimension of the parameter C. It indicates the number of columns used to define the labels for the rows. In the spreadsheet, index I labels are in the first column of the data range, so RDIM equal 1. And CDIM equals specifies the column dimension of the parameter C. It indicates the number of rows used to define the labels for the columns. In the spreadsheet, index J labels are in the first row of the data range, so CDIM equal 1. Once you have created the GDX file, you can open it in GAMS IDE. This is what you should see. In the left panel, the content of the file describes the name and type of the symbols, their dimensions, and the number of elements in each. By selecting and clicking on one of the symbols, the value for each element is displayed on the right panel. Next, we present the GAMS syntax to read the GDX file. The syntax is relatively simple. The procedure starts with the $command $GDXIN, followed by the name of the GDX file. Next, the $command $load indicates by name the elements in the GDX file to be read. In our example, all 3 elements, A, B, and C, are read. The procedure ends with a $GDXIN. Remember that for control options, the $sign must be in the first column of the line. The rest of the GAMS program is the same, but instead of having a table containing data followed by assignment statements, we now have 4 command lines that create a GDX file from an Excel file and read items from the GDX file in GAMS. We follow the procedure in reverse to export to Excel. So exporting data to an Excel spreadsheet is also done in 2 steps. First, we create a GDX file in a GAMS program. Then we convert the GDX file into an Excel file. To illustrate, we will again use the example from Lesson 2. Remember that in the model presented in Lesson 2, the objective was to find the quantities represented by the variable xij to be shipped from plant I to market J that would minimize the total cost of shipping Z. We want to create an Excel file that would include the solution variables x and z after the model has been solved and the parameter Cij. Creating a GDX file is straightforward. Since we wish to report the results of our model, the commands to create a GDX file must come after the solve statement. Execute and load is a GAMS command that creates a GDX file. It is followed by the name of the file to be created, results GDX. The name of the file must be put between quotes. Quotes can be single or double as long as opening and closing quotes match. We follow by a comma, which indicates to GAMS that what follows are items to be written in the GDX file. Next, we list the elements to include in the GDX file, separated by a comma. Note that indices are not included, and that in the case of variables, the suffix .l is added, which indicates the current level of the variable. A semicolon ends the execute and load command. Now that we have generated a GDX file, we want to convert it into Excel. You can of course open the GDX file in GAMS IDE to check on the results. If the user wishes to have all of the data translated into a spreadsheet, the fastest way is to use the GDX2XLS program. Execute is a keyword that indicates that the system command will be executed. GDX2XLS is a program that converts GDX files into XLS and is installed automatically when you download GAMS. Results GDX is the input file. It must be an existing GDX file. Result1 XLSX is the output file and refers to the Excel file to be created. The system command following the execute command must be placed between quotes, single or double. A semicolon ends the execute command. This is what you will see in the result1 Excel file. All scalars, meaning parameters, variables, and equations with no indices, are reported in the same spreadsheet automatically labeled scalar. In our case, we only have one scalar to report, the variable Z, referring to total transportation cost. Items with indices are displayed in separate spreadsheets, automatically labeled according to their names. The spreadsheet for the parameter Cij is shown here. dim1 lists the elements of the first dimension, I, of the parameter C, so plants are listed in that column. dim2 lists the elements of the second dimension J of the parameter C, so markets are listed in the second column. Transport costs are listed under the column value for each plant market combination. The results for variable Xij are displayed in worksheet X. X has also two dimensions, and similarly to C, the columns dim1 and dim2 include the list of plants and markets, respectively. But where C had only one value displayed, in the case of X, we have not only the solution values, but also the bounded and marginal values. Using GDX2XLS command to create an Excel file is relatively straightforward, but there are alternatives which might be better suited to the user's needs. We present such an option using the GDX-XRW command, as we did previously when importing data. So after the GDX file is generated, we can write, execute, a GAMS keyword, which indicates that a system command will be executed. The command starts with GDX-XRW, a program to convert GDX files into Excel format. Next, we specify the input file results GDX. It must be an existing GDX file. Next, we specify the item to include in the Excel file using the argument var equal. Finally, we specify the location where the variable should be stored using the argument RNG. In our example, we decided to put variable X in a spreadsheet labeled flow. Note that we do not need to specify the name of the Excel file. By default, it will take the GDX file name, but with the Excel extension. Since we do not specify the cell range following the exclamation mark, by default, the information will be stored starting in cell A1. As in the previous example, the system command following the execute command must be placed between quotes, single or double, and a semicolon ends the execute command. We repeat the process for each item to be stored in Excel. The variable Z will be located in a spreadsheet labeled total cost. and the parameter C will be located in a spreadsheet labeled cost. However, some differences to be noted. The argument is PAR equal for parameters and VAR equal for variables. And the suffix .l is attached to the variable's name to indicate their current level. This is what you will see in the Excel file. Note that since we did not specify a name for the Excel file, it will take the same name as a DDX file, but with the Excel extension. In the spreadsheet flow, the variable X is displayed in a table format, with the element of I as row titles, the element of J as column titles, and the solution values of shipment quantities from plant to markets. The spreadsheet cost shows the value of parameter C, also in table format. And spreadsheet total cost shows the value of variable Z. Another way to export data is by using the put facility. The basic structure is as follows. The file command is followed by the file name and ends with a semicolon. The put command is followed by the file name and ends with a semicolon. The put command is followed by the items to be exported and ends with a semicolon. The put facility allows many formatting features. They are fully covered in Chapter 15 of the GAMS User's Guide. In this lesson, we will only review a few features. As illustration, we return to our model of Lesson 2, and we want to create an output file that includes variable Xij and Z. Following the basic structure described earlier, we first assign a name to the output file. File is a command that indicates the name of the file to be created. In our example, we named the file tables. The file will automatically have the extension put. The command ends with a semicolon. Following the definition of the file name, you can add options to control the format of that file. This is done by adding an extension to the file, for example, .pc stands for print control. It indicates the type of delimiter that will separate data items. The value 5 attributed to it creates a comma-delimited file. For a complete list of formatting options and default values, we refer you to Section 15.5 of the GAMS User's Guide. This put statement identifies the file in which to write output items. It is followed by a comma. Next, we specify the items to be written in the output file using, again, put statements. A put must precede each output item. Items placed between quotes, whether single or doubled, represent textual items. Everything within the quotes is displayed. So in our example, the first put statement writes table 1 colon to the output file. The second put statement writes also a textual item, but in a different way. The output item is a variable x with a suffix .ts. The suffix .ts displays the explanatory text associated with the variable x when the variable was defined in the GAMS program. We refer you to Section 15.9 of the User's Guide for a complete description of output items. The slash means to skip to the next line in the output file. In other words, since the variable x was defined in GAMS in this way, this is what the output file will show on the first line. Table 1, comma, shipment quantities in cases. The next put statements write the description of sets on the second line. Again, the put command precedes the items to include in the output file. The suffix ts added to the set names I and j displays the explanatory text associated with each set. The slash means to skip to the next line. In other words, since the definition of I and j is as follows, this is what the output file will show on the second line: canning plants, markets. Following the descriptive items, we next want to write a table of our model results. We use the loop command to write the data since we will perform the same task various times. Remember that the loop command opens and closes with parentheses or brackets and ends with a semicolon. So at each iteration, the suffix tl added to the sets I and j displays the set labels. The next put statement displays the value of variable x associated with this element. Note the suffix .l that is added to variables to indicate a current value of the variable. The slash within the loop statement indicates a change of line before the next iteration. A semicolon ends the loop statement. Finally, the double slashes after the loop statement means to skip 2 lines. For a review of the loop command, we refer you to Lesson 6. So GAMS will first write the label of the first element of set I, Seattle, then the label of the first element of set J, New York, and finally the solution value of X, Seattle to New York, or 0. It will then skip to the next line. The process will continue for all the elements of X. Next, we write a table for variable z. Given that this variable is not indexed, the program is rather simple. This is what you will see in the output file. The first line will read Table 2, Total Transportation Cost, and on the next line, the value of the variable z, 153.68. Note that by default, the number of decimals is 2. Now, run the GAMS program, lesson7.gams. It will automatically generate the 2 Excel files discussed in the section on export data to Excel and the put file discussed in the put facilities section. All files must be saved in the same directory as the Lesson 7 GAMS file and your project file. You can open the tables.put file in Excel by following some simple steps. First, open Excel and choose Open in the File menu. Select your project directory. All the files should be listed there. Select Tables Put and click on Open. The following window will open. Choose Delimited. As you may recall, we defined the file format earlier as delimited by comma, meaning that data items are separated by a comma. Then click on Next. The following window will automatically open. Choose comma as a delimiter. Verify that quotes is the text qualifier. Then click on Next. The following window will automatically open. Click on Finish. This is what you will see in the put file. To summarize, to export data to an Excel file from GAMS, one option is to create a GDX file and then convert it into an Excel file, either by using the GDX to Excel command, which is relatively quick but does not offer the user flexibility in formatting, or by using the GDX XRW command, which requires a bit more programming but offers the user more flexibility in formatting. However, the user must be precise when specifying the location where to export the data in the Excel spreadsheet. Another option is to use the put writing facility, which offers several formatting options but requires more programming. Next, we will learn how to move from a single file program to a program with multiple files. Up until now, we have dealt with relatively simple and short GAMS files. For longer programs, it may be more suitable to divide the program into different files, either for clarity purposes or to save time when solving a model. To illustrate, we use the example shown in Lesson 5. If you recall, in the example of Lesson 5, a McDonald's customer had to choose a menu so as to satisfy a daily nutrient intake, and by selecting at least one item from each category of food. The first part of the Lesson 5 GAMS code described the set and subset used in the model. We could as well create a separate file containing the same information. We name that file set GAMS, and it contains all the set and subset definition. So in the main program, instead of having the sets description, the user can simply call the sets file. We use the $include command followed by the name of the file to access. Here, sets GAMS, shown on the right. We do the same thing for the data. A separate file named data.gams contains all the data, and this file is called from the same program. We include the file data.gams shown on the right. The $include option allows external files to be included into a given program. It is very useful when running large and complicated models. Another way of running multiple files pertaining to the same program is by using the Save and Restart option. Again, while this may not be relevant in small models, it can be very useful in larger models. To illustrate, we use the example of Lesson 5. If you recall, the main program ended this way: the definition of the model and the solve statements. Let's remove the solve commands from the main file and save them in a new file named solve.gams. Note that we do not replace the code by a $include option as we did earlier. The new code will now end this way, and we will use the Save and Restart options to link the two files. Open Lessons 5-mul.gams in GAMS IDE. In the top right window, write S equal model. You can use S or spell out save. The name model follows. It is a name given to a work file which is automatically generated when using this option. You can name it anything you like, actually. GAMS will save all the information collected at the end of the run of this program in the work file. Run the program by pressing F9 or by clicking on the red arrow icon. A work file is automatically created in the project directory. It is named model and has the suffix G00. In GAMS IDE, open the file Solve GAMS. If you were to run this file as is, you will get error messages because it is missing the definition of many elements it uses. In the top right window, write R equal model. You can use R or spell out restart. The name model follows. It must be the same name given to the work file in the Save option. By retrieving the information saved in model, GAMS picks up where the first file left off. Then run GAMS by pressing F9 or by clicking on the red arrow icon. We have now completed Lesson 7 of the GAMS training. Your assignment for this lesson is to import the data from the Excel file Lesson 7 XLSX, export the values of variable x to an Excel file using the 3 methods presented, and separate the GAMS code of Lesson 5 example into 3 parts.